All right, so in 8.2, we're going to be constructing confidence intervals to estimate a true population proportion. In 8.3, we'll be doing the exact same thing, but for a population mean. All right, so all the procedures are basically the same. But we are going to be using different sample statistics. We're going to do these things. And we're not doing them. Huh? Yeah, we got p hat here. So p hat is going to be our point estimate that we're going to use in order to calculate an interval that estimates the true proportion. In this case, there were beads. So I don't have 107 red beads and 144 beads of another color. So we just have to imagine we took random samples. So if you were to take some random samples of size 250, so there were 251 beads, and we took a simple random sample. It resulted in 107 red beads and 144 beads of another color. So that gave us a proportion of red beads, a sample proportion of red beads of 107 over 251 total. So again, we do actually use a normal distribution in order to do this. And so you do have to check that your sample size is, that the population is approximately normal by checking that n times p is greater than 10 and that n times 1 minus p are greater than 10. Just the same that we had to do when we were using normal calculations to calculate probabilities in chapter 7. So not a lot of things change. These are our conditions, the same conditions that we needed to check in chapter 7. So in this case, our standard deviation is the same, right? Sigma sub p hat. And we'll also call that the standard error as well. And because we don't know p, in this case now we're going to use p hat. So you won't be given the true proportion because we're trying to estimate it. Okay. So now we need to talk about these critical values, right? So we understand the statistic that we're going to be using p hat is going to be some sample proportion. We understand the standard deviation of this statistic, right, is going to be the square root of p hat times 1 minus p hat divided by n, the entire thing, right? We're going to be taking the square root of. But what does it mean to have a critical value for a 95% confidence? And this is a great picture of what's going on with our confidence level for a confidence level of 95%, right? Remember, using the empirical rule, that 68% of the data occurs between between one standard deviation above and one standard deviation below the mean. 95% is 2 standard deviations, and 99.7% occurs between 3 standard deviations above and below. So we're going to get critical value Z star. And that's what we're going to be calling this critical value, Z star. Yeah, we call it Z star.
You know, like just in general, like just like you like there's that
So if you look at your Z table, right, for an area that has 0.025 below, right? And if you look at the Z table for an area that has 0.025 above, right, that's a total of 5% on the outsides, with 95% on the inside. We're basically using a Z value. It comes from your Z table. You find it on the Z table. I prefer to look for it on your T table. We'll talk about a T distribution here in a little bit. I am giving you.
Oh, sweet, let's go.
So ignore everything up here. What we're looking at is this bottom row, and then the Z star value that corresponds. So you'll see then for 95% confidence, we use a Z critical value of 1.96. It is seriously, it's just coming from your Z table, right? In your Z table, you're assuming that your sample size is basically infinite. This table deals with when we have sample sizes that are definite. It is calculus. And yeah, I put there's an integral, right? It's an area below the curve. With the area below the curve, right? Your lower bound for that integral would be -infinity. Your upper bound would be this value, depending on whether you're getting right. So this value of 1.96, right? And then it calculates an area. Although that stuff inside the area inside the table is pre-calculated areas using integrals. Those areas are probability. And there we go. There's another picture of that, right? Z-bar sounds pretty cool. All right, so here we go. This is the formula for a confidence level at some percentage. This is how you're going to calculate it. Right there.
Oh wait, this is
the formula sheet.
okay.
But you have to fill in some blanks. So, where are you? Oh, there we go. So here you are for a confidence interval, right? You're going to get your statistic, critical value, and standard error. And the standard errors are here. And then you do have to know how to get your critical values, right? So you'll be given some sample statistic. Where'd you go? There you go. Yeah, so you'll have some sample statistic, in this case, p hat here. Critical value will be the Z star value that corresponds to whatever confidence level you have. And in this case, the standard error is going to be this standard error that we find here for a sample proportion. And that is it calculated, but I would much rather calculate.
Okay.
There is this 4-step process. I am going to lay out a different process. Margin of error. So it is important that if you have not been given a value for p hat, which does happen. If you're not given a value for p hat, you got to do this. The margin of error is lowest when p hat is 0.5. So if you're not given some sample proportion, you assume that sample proportion is 0.5, and that decreases. Sorry, it increases your margin of error so that you have a decreased chance of getting the true proportion. So if you need to determine an appropriate sample size, you'll use this formula. Right, you're given a margin of error usually, or not usually, every single time. What you're doing is you're solving for it. So you'd be given a problem where you're asked to find the sample size that will give you a required or a desired, I should say, margin of error. And you'll use this formula and solve for n, right? This is just z star times that sample statistic, or sorry, that sample standard deviation. And it will be a question like this. We're going to do problems. This is an example of one already done, right? Well, we'll do another one as well. All right, and there you go. Do some examples now.